Hi, everybody. Welcome to RAG Masters, a show about retrieval-augmented generation. I am Neil Katz, your host, a tech entrepreneur. And with me, of course, is the fabulous, the brilliant Daniel Warfield, a data scientist, a RAG engineer, and an online educator about all of those things and more. Daniel, how are you?
I'm doing fantastically, and I'm super excited for this conversation. We just talked about CRAG, which was like about RAG, and now we're
dragging.
yeah. Now we're talking about RAG again, but from a very different angle.
We are. Today we're going to talk about multimodal RAG, which has become a bit of a hot topic. It's a pretty new area. And I think, we're going to talk today about some of the different ways you could, like, first of all, what is it? How does it work? And then the different approaches you can take to do multimodal RAG, which essentially is just doing RAG on things that are more than just text, bringing in images and video and audio and other essentially multimedia types, which now these models are increasingly becoming multimodal, increasingly able to understand these various types, which means that we could take that next step and try to do RAG with it and bring it into our practice as well. So that's the setup. Now, Daniel, why don't you give us the framework of how multimodal RAG works, and then maybe the different approaches that engineers can take to building in applications like this.
Yeah, so I whipped up a few diagrams, and I'd like to share them. So the first one is essentially...
And by the way, viewer beware, I just want to say importantly, and we discussed it before the show, that this is not going to be the exhaustive everything you need to know about multimedia RAG. This is going to be the intro to multimedia RAG. We're going to leave some things on the table, and for future episodes that we can really, really dive deep, maybe on one or several of these techniques. So with that, jump back into it, Daniel. What are the different ways? Give us a sense of what's multimedia RAG, how does it work, and the different approaches.
Gotcha. So multimodal RAG is essentially the idea of it's normal RAG. So you build a retrieval engine that can ask a store of information about information. So like if you have a question about something on the internet, or you have a question about a specific topic, like what's the color of the Eiffel Tower? The idea is the retrieval engine can grab stuff from some store of documents. Then it can inject that into a prompt so that you say, hey, check out this information I saw on the internet. Also, the question is, what is the color of the Eiffel Tower? So you take the information that answers the question along with the question itself, and you pass it to a model for generation. That's like classic RAG. But kind of the interesting thing is now we don't just work with text anymore. We have multimodal models that can understand usually text and images at least, but now we're getting audio and video and all sorts of stuff. So what if you have some expert who's been talking about the Eiffel Tower for the last decade, and he just happens to mention that, oh yeah, it's called Eiffel Tower brown is the color of the Eiffel Tower. So now you have that information in audio. Wouldn't it be cool if you could retrieve information from audio as well as text and images, and then inject that to a language model for generation? That's the core idea of multimodal RAG.
Or if you just had pictures of the Eiffel Tower, in theory, you could ask the question, what color is the Eiffel Tower?
Yeah, or if you have
text about it.
If you have a video of some guy who's like showing a panorama of France, and one of the frames contains the Eiffel Tower, then you can extract that potentially if you have a proper model that can understand video as a modality.
Yeah, I mean, that's just so exciting. It just opens up the entire world, really, and more. If I just think about the universe of human experiences, like we don't really exist in a textual world in our real life. Mm-hmm. We narrow ourselves down into web browsers or books, but to be able to bring all the sensory experiences potentially into language models and then talk to them and build applications around them and build RAG search around them, that gets super interesting to build the kind of applications I don't think we've ever seen before.
Yeah, absolutely. I think we talked about this a few episodes ago. There was GPT and their unveiling, and they had like they were taking a video and showing it to GPT, and they were like, hey, what's this? What's this? What's that? And they were moving around, and they asked a variety of questions, and they're like, hey, do you remember where my glasses were? And it was like, oh yeah, I happened to see that in the video. It's right next to the apple, right? And it's on the desk over there. So like the ability to retrieve this information, then use it to build performant applications is exciting. It also probably, well, almost certainly opens up a lot of security, ethicality concerns naturally. And that's important to keep in mind. But if we're keeping it light, as a data scientist, and
let's not go Big Brother yet.
as a data scientist and developer, and people who want to make cool tools and cool technology, it's a super exciting general paradigm.
Yeah. Okay. So let's jump into it. Why don't you explain the different approach that currently on the table? I think this sounds like there's broadly three approaches to putting this into practice. Why don't you break that down for us? Maybe show some of the diagrams so people can really dig into the details.
Gotcha. So this is the first one. So this is kind of like when a lot of people talk multimodal RAG, this is what they're talking about. So you have some sort of model. So there are these three boxes here: the audio encoding, the visual encoding, the image encoding, and a text encoding, for instance. Yeah. You can kind of think of these as three different models within a larger model, right? So usually you have a single model that's been trained to encode different types of data. And it has to be trained together, because that means all of the encodings, all of the representations it makes for audio, images, and text, they need to be comparable in some way. So we don't have to go into the crazy modeling right now, but basically you have some store of different types of data, and you pass it to this large model that has different encodings for audio and images and text. Then these different encodings summarize all of your inputs as vectors, right? So an audio waveform might be this vector, an image waveform, or an image example might be this, a text block might be this, etc. And then you can kind of put those in what's called a vector space. So now that you've said that everything is represented as a vector, you can put them in space, and then you can also put your query, your question, what color is the Eiffel Tower? You can put it in the same space. And if you've trained these encodings properly, there should be some element where proximity matters, right? Like if it's good at clustering things that are similar and separating things that are dissimilar across a variety of modalities, then you can just look at the vectors that are close to your query, whether it be text or whether it be images or whether it be audio, and then extract those. And then you can use that for augmentation and generation. So you build your augmented prompt, and then you pass it to the model for generation.
So let me just play this back to you for a second. So, in this approach, it doesn't really matter what your modality is. A multimodal model, like we increasingly see from Google and OpenAI and others, Anthropic, can encode any of these sources and then store similar information in close proximity in a vector space. So to make it concrete, for example, if I had a paragraph of text describing a couple romantically kissing in front of the Eiffel Tower, and I also had a old photograph from World War II of a couple kissing in front of the Eiffel Tower, elements of both those pieces of content, even though they're totally separate, elements of both those pieces of content would be stored in somewhat of proximity in the vector space, even though they start out as completely different objects.
Yeah, that's completely right. And you're actually touching on a big issue with all of these, right? So we're going to talk about a variety of approaches to multimodal RAG, but they're all still RAG. And the state of the art right now, and there are a lot of ways to get around this, but the state of the art of RAG is imperfect, and it likely always will be, right? When is technology ever perfect? Sure. One of the current issues with RAG is temporal changes. Like if you have a question if you have a document store with 20 million images of the Eiffel Tower, some of which are from the 20s, some of which are from the 50s, and some of which are from like 5 minutes ago. Like the color of the Eiffel Tower changes. I was Googling it. It like one time it was gold for the Olympics, and then another time it was another color. So even something one would consider to be stagnant often isn't. So if you're
color today or now or in general, these are very different questions, right?
And if you're building a RAG system, like how do you bake that in? Like what if you have images that don't have a label in terms of when they were taken? What if someone copied an image from the 60s and then save it to their Google Drive 2 minutes ago? So now the metadata in the image is from 2 minutes ago, but the image is from the 60s. So like all of these approaches inherit the same general problems of RAG.
That is an interesting point. That is an interesting problem. we imagine these are black boxes. They're genies. You can dump anything into them and they instantly figure out everything. But there are, almost infinite ways to fool it accidentally into giving it data sets that will trip it up later on.
Yeah, absolutely.
Okay. Why don't we take a look at number 2? What's the second approach to do multimodal RAG? And let's bring up the diagram if we can.
Yeah, absolutely. So that was the first example. We have this idea of kind of like a joint embedding that they all kind of work together and you can put everything in the same space. But that's a tall order, right? Like Google,
that's using one model, one encoding model that can handle whatever, anything you throw at it. And Google made a big announcement recently, so did OpenAI about this. So this is where the models are increasingly trying to sell this aspect of what they can do.
Yeah, but what if you don't like the way it encodes audio? Or what if you want a little bit more customization? There's a variety of reasons. Maybe you don't want to send your data to Google. There's a ton of reasons that
you want to fine tune the image encoder based on the images that matter for your company.
Exactly. So there are a variety of other approaches. One of them is to use a grounded modality. So this is actually what our company does. There's a variety of ways to do this. But basically, what if you take your audio and your images and then you pass them, instead of through an encoder that all these encoders can play nicely together, what if you turn them all into one modality? So what if you describe your audio as text and describe your images as text?
Right.
Then you have, your textual information, your query, those are all text. Your images are now text, or they're represented as a description in text, and audio is represented as a description in text. So now you have a bunch of text. And now you can just use a text encoding. So you have one model that's trained to summarize a block of text as a vector. So now you can kind of stick all that information in there in a vector store and say which blocks of information are similar to my query. And this is kind of interesting because you can there's so much room to play around in this space. If you have a multimodal model, like Google Gemini, for instance, you can choose to extract the image. If you are dealing with an LLM, you can choose to extract the textual representation of the image. There's you can make a lot of decisions here in terms of how are you doing the summarization? What do you care about? What are you giving to the final model? You can do multimodal RAG in this sense without having a multimodal model, which also is kind of cool because multimodality is fairly new. And if you want to build a robust solution, sometimes it's better to just stick in a textual modality.
But you're going to, if I understand, you're going to need a multimodal model somewhere in this chain, or these specialized models to handle essentially translating the images, the videos, and the audio into text. This at eye level, this is what part of what our GroundX APIs are doing. We're kind of normalizing in a way. Whatever you bring in the door, we're going to normalize that into well-explained text, on the theory that even though the models are increasingly multimodal, their comfort zone, their sweet space, the comfort space for them really is text. They started out as text machines, and that's still where they're strongest. So our theory at least, the best thing to have in your RAG database is text that language models understand. But that may not be true in 18 months from now, or 5 years from now. It might even be true in 6 months. We're going to find out. So what, in your opinion, what are the pros and cons of this approach versus what we just saw in the first approach, where we just hand it all to a multimodal model and say, you figure it out. You do these embeddings. We're not going to pre-process anything. Your problem.
Yeah. So there's a ton of advantages and disadvantages. I was just giving a talk at PMG, and a bunch of people asked me, how do I choose the right approach generally? And honestly, my answer...
Vibes. That's your answer to everything, Daniel. Vibes.
Yeah, it's hard. It's really hard. And it has to do with your specific use case, and it has to do with your specific needs. If you're working in a text-heavy environment and you want to be able to audit things via text, understand things in a textual language, if you're building tooling around text and you have 4 images that are just floating around and some guy talking, you probably don't want to deal with the overhead of having a highly complex multimodal complete system, Also, it kind of depends on the questions you're asking. We did an article on it was RAG battle, having RAG systems competing against each other.
Yep.
And sometimes summarizing images via text, actually a lot of the time we've found, which is kind of why we chose the solution to summarize via text. A lot of the time, a lot of these models can summarize an image in terms of text that is worthwhile, but sometimes it doesn't. If you have like a big image with a lot of stuff going on and you really care about the background color of the image or like how many clouds are in the background, the image to text summarization model might not deem that information relevant enough to be in the summarization. So then that information essentially disappears. And you could make an argument that vectors perhaps have a similar problem. Like you don't perfectly encode anything into a vector. So, all of these
unclear right now, right? Which of those is providing more completeness and precision and accuracy on your original which one's more faithfully representing in the database what was originally there? I think it's a little unclear right now, right?
I think so. And I think so there's a big push in academia for robustness. And this is a little easier in academia because we have like pre-made solutions. We have data sets. We have like entire things. Like academia works really hard to build benchmarks for direct comparison. And we're kind of fortunately, depends on who pays you and what you get paid to do, I guess. But we're kind of getting to the point where it seems like entire architectures might need a similar level of robustness, or maybe you need to build more than one architecture, perhaps, to know which one's good. Maybe you have to play around with all these things. Maybe you have to play around with them on a large scale. So that could be really challenging, but it also presents a whole new range of engineering opportunities, which I think a lot of people are kind of excited about.
All right. So what's method number 3, and how is it different from 1 and 2?
Yeah. So method number 2 uses a grounded
graphic there. Yeah. Great.
Yeah. Method number 2 uses a grounded modality. So everything gets represented as text. Method number 1, we didn't care about that, right? We just used a single model to encode everything. The third approach it looks more complicated, but actually
it does.
It's pretty simple. So on our first example, we had one model that had multiple encodings that could work together. But this can be hard to find. It's becoming increasingly easy to find, but there's only a few vendors that you can really choose from. Maybe you want to deal with smaller models. Maybe you want to train the models yourselves, and you don't want to build a model that can understand multiple modalities simultaneously. So what you do is you use several different encoding models that do have joint alignment, right? So maybe you use a model that can understand audio and text. Maybe you use a different model that can understand images and text. And maybe you use a third model for just text. So then you essentially do encoding depending on the modality across a variety of encoders. So for instance, up here, you take all of your audio data, you store it in text, and this particular large model understands both audio and text. So you pass them all through, you have a vector space, then you choose a few audio forms that you think are useful and worthwhile. Then you have a bunch of images. And so you have another model that understands images and text. It doesn't understand audio, but now you can pass all of your images through here, pass your question, then find the images that are relevant to your question. And then you can do the same thing with text, because now it's all text. So then you just have a model that's good at embedding text just by itself. So then you essentially do retrieval multiple times, depending on which embeddings you're choosing and how broad they are. You might do retrieval like 1 time, 4 times, 10 times. It really just depends, right? And then you end up with a bunch of information that a bunch of different retrievals have said, this is relevant. So then you can pass it through a re-ranker.
Seems like you must have to. I mean, you've got 3 searches done in parallel, like 3 piles of data here. How do you figure out essentially what to send the language model? You can't send it all.
Yeah. So I mean, like naively, so there's a lot of ways to do retrieval, right? I'm summarizing it here in these diagrams, but you could, for instance, you could just say, if this one was closer to the query than this one is, then this one is more useful than this one. So you could use a little bit of data science trickery to get around the need for a re-ranker. You could also just choose the top N from all modalities.
Right.
You could say, I want the best.
What
was that?
give me the top 5 in audio, give me the top 5 in image, give me the top 5 in text, and we're done.
Yeah, exactly. Or you could use a dedicated re-ranking model, and those exist. And if they work in the modality that you're dealing with, and also you've validated them and stuff, adding complexity, it's cute and it's fun, but also now you have to validate it. So it might be really good, or it might not be really good, and it's up to you as a sort of RAG engineer, I think, to really come up with these decisions. But you could pass this through a re-ranker that very cleverly, with a bunch of data science magic, decides to re-rank these. Now you have a bunch of data, you can pass it through augmentation and generation. So those are like the three, at least that I've seen, those are like the 3 predominant strategies for doing multimodal RAG.
All right, so we've got method 1 is I take one multimodal model, I throw everything I've got in it, it's going to put them all in the same vector space, and you do search on that giant pile of data, regardless of what modality it is. And method 2 is basically we translate, no matter what you've got, you translate into text first, and you vectorize the text on the theory that language models still are stronger in general in working with text. But you now have this disadvantage. You've translated one thing to another, and if that translation isn't right or complete, you've lost some things. And you've got this third method, it sounds like, where you take, you have multiple models working in different pipelines, sort of like you split it out, create 3 different embedding spaces, or as many embedding spaces as you need, and then you have to search them all, I guess in parallel sequence. You decide how you're going to build the program, and then try to sort out those results and send something sensible eventually to the language model to say something about it. Which one do you like? I mean, what's the is there a state of the art, or these are all just competing right now and we don't quite know who's going to lead? Or is it that actually they're more built for specific use cases?
Yeah, so given an existing benchmark, there is always a state of the art in academia, right? Like if you look at a specific type of problem, then you look at the specific paper that solved that problem in that way, right? And in academia, we basically just talked about the business approaches to multimodal RAG. In academia, we talk about this a little bit in the CRAG, the one we did previously, the CRAG podcast. In academia, it's completely different. The priorities are different. The objectives are different. The way they conceptualize RAG and how it fits into the grand scheme of things is essentially completely different than business. So in a business context, that's a much more difficult problem, or difficult question to answer. I think probably, one of the most compelling is to use a advanced RAG approach that is integrated and built together, right? So we have like Google, they have like their like really.
You're going for option 1 here, one big mama jamma model that does it all for you.
So if you're going with Google, you don't have to do much, right? Like you don't have to do a lot of extra stuff on top of it, right? You just pass it through their multimodal embedding, you choose the best one, and then you're off to the races. I think the other approaches have a lot of merit.
Easier to get started, but when you finish, I'm going to push back, because I think there's some reasons why you might want to choose one of the other paths. But go ahead.
Yeah, but it's not the approach really. It's not that I like the first one more. That's the easiest one to be like well thought out and integrated. I think
you're outsourcing the problem. You're like, hey Google, I think you're smart. Go solve this. I got a pile of stuff. I got 3 piles of stuff. You sort it out.
Exactly. But the other approaches have a lot of merit, and you can tweak everything and you can improve them. I think really the question is are you willing to? Like, are you willing to go through the difficulty? Because everyone loves throwing out these diagrams. We love being like, wow, look at this cool approach. Look at that cool approach. And it really comes down to the specific types of documents or information you're dealing with and what you're trying to apply it to. So I would say the answer is the best approach is the approach that you can do to a heightened degree of performance, right? If you don't have the utility.
Engineering cheat answer. I'm usually the business guy in those meetings. How many meetings have I been in where I get that kind of answer from an engineer? That's so not an answer.
Well,
which one? I'm the guy. I'm like the customer. Which one's better? Well,
Well, so it depends on how hard you want to work, right? If you want to work really hard, go with whatever approach kind of makes sense for your use case. But I think realistically, the vast majority of people, they want to implement RAG in a product. They don't want to be, crazy RAG experts. So I like our offering. Naturally, we have a pre-built solution where we use kind of option 2 and then a lot of things on top of it. Google has option 1, and obviously they've worked really hard on that. They have a massive media campaign and all that jazz. I think at the end of the day, it's the one that you can grab quickly and test and make sure that it works in your use case. I think that's really there's a whole angle here, which is how quickly can you deploy this and how quickly can you make sure it works? Like, because if you have to do all this effort and then you realize it sucks, like that's horrible.
For sure. Maybe I'm biased, but I have a preference for modes 2 or 3 because the model wars are heated and ongoing. And, every 3 months, basically, they leapfrog each other. And I prefer having the flexibility to say, hey, Google might be better at images. Anthropic is, at this point for a couple of quarters now, a lot of people prefer its writing output. So it might be better textually. GPT-4o seems to be really strong on graphical understanding. So I like the idea of being able to basically pick and choose the models that are right for that particular data type, and then changing them as you see fit, as they leapfrog each other. But if you outsource all your trouble to one vendor, you're kind of stuck. I guess you'd have to hope someone would have to come along to replace all 3, and you get a little bit of lock in there. And I think I prefer the optionality, but there's more work for sure. Now you're writing 3 pipelines, and you've got to manage these problems.
Yeah, it's not easy. And also the sand shift, every week, right? Like, what if then there's like an amazing multimodal model that just kind of kicks butt, and then now you have this, this sort of separated thing, so you have to somehow align these systems.
But I might argue you could still have the option of using, if you've built you've separated out the pipelines, you still have the option of using the same model for each one of those pathways.
Yeah, in theory, right?
In theory, but it might, what if it's not in the same embedding space, and does that reduce the quality of the search?
Yeah. Or what if you are just assuming everything's text now, and then you have some weird process that you have been relying on for the last year that now you need to go away from a text-only encode. So there's like the engineering quirks of it's a really tough time to know what to do. And actually, I think this is really an extension. This is really an extension of like the shift between academia. I keep talking about this because I think it's really maybe one of the most poignant problems is we need to build products out of this stuff, right? Like that's the whole goal. That's what everyone's scrambling for. Big companies, small companies. We're taking this technology and we're like, how can we make it actually useful and good, right? And I think that
I'd say and also in the business world, like you're kind of stuck with your decisions for a while, even though things are leapfrogging all the time. It's not practical to change the parts of your machine every 3 months. So you kind of sometimes have to make a choice, and then that's going to be how your application works for the next couple of quarters, maybe the next year at least. And you have to live with that, even though things might be percolating around you. You need stability in your code, you need stability in your products, even if you're missing a little bit of that new edge.
Yeah, I lost my train of thought, but you brought me back to it. Thank you.
It's all right. I jumped in with a different train of thought.
No, very, very similar train of thought. Okay. So yeah, like we need stability, right? Like we need stability, and academia has been fighting for this tooth and nail for a long time. Of like what's the good way to do stuff? And obviously, there's a lot of experimentation. People are playing with all sorts of approaches and stuff, but academia is aligned around benchmarks, whereas in business, everyone's kind of in their own camp and they're all kind of living in their own world and stuff. Mm-hmm. And that actually academia is kind of adopting that too. Like OpenAI has been more closeted about their research. Basically every large language and AI company has been very closeted in its research, but it really seems like we need to start maybe working together a little bit. Meta actually has had a really good strategy around this. So I was listening to a podcast that Zuck was talking in, and he said, like, if basically anytime we can open source stuff, we do, right? Like if it doesn't even hurt us, maybe there's no benefit, but if it doesn't hurt us, we open source it.
Oh, he's a man of the people now. That's that
Well,
must be he's an elder statesman now that he's getting his ass kicked in Congress every now and then for really destroying American teenagers. But I'm glad that he's got this spirit of generosity now.
yeah, I mean, look,
Business.
I'm a certified social media hater, right? So,
Yeah,
but
you don't even on it, right?
yeah, no, I'm not. But
Barely, a little bit.
a smidgen. But what's cool, but the reason they do it isn't because, and he was pretty clear about this. He doesn't love like giving to the people, right? Well, maybe he does. I have no idea. I'm not inside. But what the reason he does do it is like they open source their architecture for how they built servers and large systems and stuff like that. And then a lot of people were like, oh, that's how they do it. Cool. We'll do it a similar way. And then the entire industry sort of convolved and like joined around the way they did things. So then hardware vendors started building things around that framework and all sorts of stuff. So by open sourcing and making their strategy ubiquitous,
because they're so big, because other people will build into their ecosystem and save them time and money. And there's a whole group of partners and technology companies that can provide services to them. I forget where you're going, because they've laid down the framework of, hey, this is how we want to work. We're rich. We buy a lot of things. You should work the way we want to work too.
Yeah. So maybe we just need to pick one. Or maybe at least like someone needs to come and say, hey, so we have this, we know that these frameworks exist. So we've built an open source platform so that we can kind of join them together. And there has been work in that in terms of like LangChain and Llama Index and stuff like that. The open source community around AI is currently highly bubbling sort of ecosystem, but it really seems like we really need alignment from like a corporate perspective. Maybe that's not the solution, but maybe that is a solution.
It seems like a nice, juicy topic for another show: open source versus closed source versus whatever actually is happening now with these models, which really isn't one or the other. It's sort of like you can use it on a license, but they don't really show you the code behind it or all the weights and biases. So anyway, that's for another show, because that's a big topic. But thank you, Daniel. That was a great journey through Multimedia RAG, where we are today. I know this is not the end of this topic. We're going to come back to here again and again, because it's really interesting and lots of people care about it. So that's all for us. Thank you guys again for watching RAG Masters, and we'll see you real soon.